Hello everyone. Before starting today's topic, let us do this activity. Now, in this video you can see that we are going to have streams of water. Now in this stream of water, I will keep a seed and this is kept normal to the flow of water. So another side water is coming out in a good quantity. And if I will change the position of the seed like this, then from one phase to another phase, in this case no water stream is flowing, and in this case when it is kept perpendicular, maximum water streams are going from one side to another side. Another thing that I will do now, I will change the flow of water. I am reducing the speed with which water is coming from this side. Now see, when I have kept it normal, then now water that is flowing this side is going to be less. Further reducing the speed, less water. It means water collected another side will depend on two factors: the speed with which water is flowing and the placement of your surface. So today we will talk about one more quantity, that is electric flux. Flux means flow, and electric flux means we are talking about flow of electric field lines, though electric field lines are imaginary. When we will consider definition of electric flux, then according to its definition, electric flux through a given area or surface is defined as total number of field lines passing perpendicularly through the surface. Meaning of this definition is, when we will consider like this, electric field lines are going like this, in this way, and this is the surface under consideration, this particular part. So electric field lines are coming like this, in this way, and this is kept perpendicular or normally. These field lines are falling normally. Now normally how many field lines can come out through this surface gives us the value of electric flux. When we will consider this topic in more detail, we will consider it in various cases. Case first, when we are going to discuss, in this case we will consider presence of uniform electric field. This uniform electric field we are representing by equally spaced parallel lines. So here I have shown with green lines the field lines. Here also I have used green color to show field lines. Here field lines are closer, here field lines are far apart. So this difference shows us that here the strength of field is more and here the strength of field is less. So if I will consider a surface that is kept perpendicular to the direction of field lines. So a surface that is kept perpendicular to the direction of field lines means this is the surface and field lines are going like this. So field lines are perpendicularly crossing this surface. Now how many field lines can cross this given area? That will give me an idea of electric flux. Here more field lines will be able to cross this area, so flux will be more. In this case you see 1, 2, 3. 3 field lines are able to cross this area, so here flux will be more. In this case field lines only one is able to cross from one side to another side, so here value of flux will be less. It means flux is dependent on the strength of electric field intensity, because more closer will be field lines, more flux will be able to, more field lines will be able to cross the area. In this case flux will be less, in this case flux will be more, because here electric field intensity is more and here electric field intensity is less. This is the case when we have changed the value of electric field intensity, but the position of the area we have kept normal to the direction of electric field intensity. Let us consider second case. Field we have uniform, but we are changing the position of the area when we will consider different cases. So for first case, I have shown this line. This line is representing, see, the area under consideration will be this. This is representing B, this is representing L. So when I will consider like this, if you will see in this way, this portion is visible. So this diagram is representing this area whole. And if the same I have shown here with one line, how will you be able to see one line? If you will see from this side, then this line is only visible to you. So this line I have represented in this diagram by B. This length, this gap is represented by B. Now this is perpendicular to the direction of field lines. So here flux will be maximum, or flux more and more field lines will be able to pass. Let me consider now this area is not normal to the direction of field lines. I am shifting it like this. Like this I have shifted. Now compare this diagram with this. Now field lines which are coming from this upper part, they will not be able to cross this surface. Now number of field lines will be reduced. In this case, number of field lines crossing this surface will be more. In this case, when I have changed its position, number of field lines crossing this surface will be less. Why? Because now the field lines which are coming from this particular area will not be able to cross it. They will go straight. Now how much effective area we are going to have? Effective area will be this, means multiplication of this with this. Now this gap is L and this gap is B dash. So effective area will become L B dash. And in this case, what was the effective area? In this case, effective area was L multiplied by B. In this case, what will be effective area? Effective area will be L multiplied by B dash, and this is angle theta by which I have shifted this surface. So same you try to see here. In this case, this is B dash, this is representing B. How much is this effective area? Effective area will become L multiplied by, area value will become L multiplied by B dash. Now we have to calculate value of B dash. What will be value of B dash in this triangle BOA? This is angle theta, this is B dash, and this is B. This is B dash, this is B, this is angle theta. I want to find out value of B dash, and if you will join this line, this angle will become 90 degree. So when you will find value of cos theta will be B dash upon B, base upon hypotenuse. So B dash will come out to be B cos theta. And how much flux is passing through this? How many field line, electric field lines are crossing it normally? For this we will use one formula, and we will use this definition that electric field intensity gives me the number of field lines passing through unit area. If area is unity, the number of field lines crossing through it normally or perpendicularly I will represent by E. So if area is unity, number of field lines crossing I will represent by E. Now how much area do we have here? Area is LB dash, or area is going to be LB cos theta. Now if area is unity, number of field lines we will represent by E. If area is LB cos theta, then how many field lines will cross it normally? It will be ELB cos theta. Same is mentioned here, ELB cos theta. And what is LB representing? LB is representing the area of this surface that is under consideration. So this I have represented by EA cos theta. This is just like AB cos theta. And in 11th class you have done dot product. So I can write it vector E dot vector A. E is a vector quantity. Electric field intensity you already know. But I have made here vector also to area also to be a vector quantity. Here I have used magnitude of this area. But here I have represented area to be a vector quantity. Now how to justify the direction of this area vector? the direction of area vector is considered in such a way that it is making an angle theta with the direction of E. So to find this theta, we will consider this diagram again. How to consider this diagram? In this diagram you see, if I will consider this figure, electric field intensity is in this direction. So this direction I have represented by this E. This is representing B dash. This is B dash. This is B. This is B. This is angle theta. This is angle theta. If I will consider a straight line, then this angle will come out to be 90. This angle is 90. Now in this triangle, one angle is 90, one is theta. What is third angle left? This angle. This angle will come out to be 90 minus theta. If I will draw a normal on this surface, normal like this, normal I have drawn, then if I will consider this straight line, in this straight line, the sum of angles, which angles I am going to consider? This angle and normal drawn. So this angle and this angle, their sum should come out to be 180 degree. So in this diagram, just focus, this is 90 minus theta, this is 90 degree. If you will consider sum of all these angles to be 180, then this angle will come out to be theta. Or you can see whether their sum is 180 or not. 90 minus theta plus 90 plus theta will give you 180 degree. So what will be the direction of this area vector? Direction of area vector will be normal to the surface. You have to consider normal to the surface. And if you are going to have a closed surface, then this normal will be in outward direction. So theta is the angle which the normal to the surface, this is normal to the surface, making with the direction of electric field. This is this theta. And if this theta will be 0, cos 0 will be 1. So electric flux will be maximum. Just focus in this case. Normal to surface, electric field intensity in same direction. Flux is going to be E delta S. Same is going to be here. But here strength of electric field intensity is different. Here we are going to have again same. But in this case, theta is not equal to 0. And if theta will become 90, then what will happen? If theta will become 90, then flux will become 0. What will happen if we will consider the case of electric field intensity which is changing? In case of non-uniform electric field, we will divide our surface into small area element. And we will use the previous formula for each area element and we will add. Then total flux will be summation of dot product of electric field intensity and area element. If you will consider what is the unit, 1 mark question, what is the unit of electric flux? Then electric flux is dot product of E and A. And unit of E is Newton per coulomb. And area is meter square. So its unit will be Newton meter square per coulomb. If you will consider unit of E to be volt per meter, then electric flux unit will be volt per meter multiplied by meter square. This will be volt meter. So I hope this video will help you to understand the concept of electric flux. After this, you can try the numericals related to this.